What's going on, electronics and robotics? This week we're going to be working on a solar panel controller. So when you have solar panels, sometimes solar panels are fixed. Actually, often solar panels are fixed to a roof and they don't rotate. But there are examples of solar panels that do rotate and follow the sun. A solar panel that follows the sun is going to be more effective than a solar panel that is constant just because it's always going to be perpendicular to the sun's rays. But when you go to control those, you need to have some sort of an input and some sort of a motor. And typically, towards the end of this year, we would be building one of those in class using a servo and a couple photocells. So we're going to kind of go through that process today. So I've taken and created a copy of last week's assignments. And, we can control using a map and using the potentiometer the direction that our servo is going to spin in, which is great. We're going to replace this control system instead, though, with some photo cells. Okay, so let's just do a quick little search and type photo. It'll probably come right up. So photoresistor is actually what we're looking for. We're going to need two of these. So a photoresistor is um, it's just like a potentiometer, except this potentiometer, we adjust its value manually. A photoresistor, it adjusts its value based upon light hitting it. Okay, we actually use photoresistors in our nightlight project that we did really close to the beginning of the year at this point. So we're going to need to set up two of these, typically on a photocell or on like when we do a solar rig, we would have one on one side of the solar panel and one on the other side of the solar panel. Now, there are no solar panels here. So what we have to do is we have to imagine the fact that there's basically a solar panel on the servo horn here. And essentially, when more light hits this solar cell, so photoresistor, it's going to cause we're going to want the servo to turn towards it. And when it hits this photoresistor, we're going to want it to turn towards that one. And when they're equal, we want them to be stationary. Now, usually these would be moving with the solar panel themselves. So again, we have to use kind of some imagination here because that's not going to be able to happen. But we're going to use some control system, some control structure, some like if-else statements to be able to control when this one's brighter than this one, it's going to do one thing. If this one's brighter than that one, it's going to do another. And then if they're both about equal to one another, then it's going to sit still. All right, so let me go through and wire that up quick, and then we'll come back to this. All right, so I have the first photocell wired up, and I'm going to show you exactly how to wire up the second one. But I just want to show you real quick before we do that. When we click on the photocell itself, we can control if it's either getting dark or if it's getting lighter. Okay, and as it gets lighter, we want this servo to rotate in that direction. Okay, so because this photocell is to the left of here, we want this to rotate to the left the closer, the brighter it gets. Okay, so the darker it gets, basically the further away it's going to go. Okay, so in order to do this, you're going to need a couple of different things. So we're going to do this exact same process again. But the first one, I have my left one is connected to A0. I've already connected the ground to this one here, but we're going to need what's a pull-up resistor added to this, okay, the third leg of this. So in order to make that happen, we're going to first start off with our basic wiring. We're going to have one photocell go to like A0. The other one can go to A1. It could go to any of your analog inputs. Since I already have a green wire, I'm going to change this to be a different color. Let's say purple. And then what I need to do, if I go to if I were to start my simulation right now, well, actually, let's go back to the original one here. Let's start the simulation. Let's just look at this one here. You can see that I have an input value and an output value. But if I were to, like, let's say, get rid of this wire, so now that's not connected to 5 volts through the 10 kilo ohm resistor, notice that the value is 0, okay? That's because there's nothing going between ground and 5 volts in order to give us our potential difference. So if we just directly connected this, like if we didn't go through the resistor at all and we just went like this, then it would always read high. It would never matter what it is. It would always read as high as it could go. So in order to make all this work, we need to pull up resistor, which is going to go from whatever analog input you're using through a 10 kilo ohm resistor into then 5 volts. Okay, so if I take my A1 and I drop a wire down from there, sorry, A1 down and over. I guess I need to put in a resistor first. So let's do that. So again, resistor here. I'm going to rotate my resistor up top here. I'm going to change this to be a 10 kilo ohm resistor. And I am going to wire that up to A1. And I'm just going to use a red wire because ultimately this is going back to 5 volts. So make it easier there. So I connect my red wire up there. And then on this side, I'm going to connect that to 5 volts as well. And now we have our pull-up resistor sets so that we will be able to get readings on both of these. Okay, so let's run to our code quick and let's do a couple different things. So instead of this just being called a pot that's connected to A0, I'm going to call this left. I could say, like, let's say left photoresistor, PR. Okay, left photoresistor is equal to A0. I'm going to create a new integer, which is going to be called right photoresistor. That's going to be set to A1. So we need to change this so that it says left photoresistor is an input and pin mode right photoresistor is also an input. Okay. And a lot of this stuff down here, we're going to have to tweak down in the bottom. So what we're going to do here is we're going to say, okay, so left value is going to be an analog read of the left photoresistor. We're also going to create a new integer called right value, which will be set to an analog read of the right photoresistor. By the way, both those things, left and right, will need to be changed up here. So I have pot value. I'm going to say this left value, integer right value. And I know instead of saying like input value for right now, let's just actually print up the left value, which is going to be here. And let's get rid of this map for the moment, or I guess I'll just comment it out, get rid of it. And then we're going to say right value. And that's going to output the right value. And we're going to get rid of the servo thing for right now. So when we go to start this, let's see here, right value, oops. So when we go to start this code here, and we look at our serial monitor, both of these are reading 969, okay, because they're here. As I slide them further this direction, my left value has now dropped down. Okay, the brighter it gets, the lower the resistance is going to be. To the point where it's like at its lowest value here is 49. Its highest value here is 969. Probably the same thing is true for this. 969 all the way down to 49. Okay, so those are the two values that we're going to basically be controlling. And we're going to control all of these through some if statements. Okay, so let's stop our code here, and what we're going to say, stop. So we're going to say we're going to do three if statements. Okay, so we're going to create a first if statement. If our left is better than our right, we're going to move it to the left. Okay, and if our right is greater than our left, then we're going to move it to the right. Actually, it's going to be less than. Doesn't matter. And then the other thing is if they're equal to one another, then it's going to stay still. All right, so first of all, actually, let's do servo. What do we name this servo? Example dot right, and let's just start off by sending this thing to the middle of its travel. Let's do that up here instead. Let's put it in the middle of its travel, and let us delay for 1 second and just wait for that thing to move. So when we start our simulation, and at this point this is now in the middle. We're ready to move on to the rest here. Okay, so let's give that a go. Just going to increase that. Okay, so down here, we're going to say if left value is less than right value. Okay, so what does that mean? That means that there's more light on this side here, right? When we look at our serial monitor, left value is 61, right value is 900. Okay, so because left is less than right, it's going to go into this if statement here. Okay, so we're just going to say if left is greater than right, we're going to say example dot right. Let's try 0. I really don't know which direction that is. Okay, so we're going to say start 0. And so there it's in the middle. As this thing goes, let's see what happens to it. See, we're tracking now in this direction, which is exactly what we want it to do. Let's say that it was going in the wrong direction. Instead of going to 0, we're going to say to 180. Okay, now when I go to update this, you're going to notice that now it's twisting in this direction here. So again, if you needed to flip-flop your directions, you could do that just like that. Okay, so if left is less than right, this thing is going to rotate towards the left, which is exactly what we want it to do. I think I'm just going to delay in between these about 50 milliseconds so that every time it's going to go through this loop, it's going to start moving it in that direction, but only for 1/20th of a second. And then it's going to check it again and then see what it can do at that point. All right. So that brings us into our next if statement, which our next if statement is going to be that our right value is less than our left value. Okay, so the exact opposite of what we have up top here. Then in bracket, put some information in here. We're going to say example dot right 180. That's going to cause this thing to rotate the opposite direction. And again, we're going to delay for 50 milliseconds. And then lastly, if right is equal to left value, forgetting the value part. Okay, so this is it when they're both exactly the same. we're going to do nothing. Okay, we want it to just stay exactly where it's at. So technically, we should probably detach this. So let's do that. Let's say detach dot example. I think that's how I detach that. But if we're going to do that, we also need to attach example, attach dot example dot, and then in 7 here. So I'm going to put that in both these. So every time I go in, I'm going to attach. And then, except for if they're both the same, then we're going to detach them. Okay, so let's start the simulation. Sorry, it seems like your code, let's see here. Example.attach. Oops, that would help. Okay, so let me change that quick. Yeah, so it's example.attach, and then, or whatever your servo name is, .attach, and then your number. And then to detach, it's going to be example.detach, or again, servo name.detach, and we'll move it. So when we start our simulation, again, the servo starts in the middle. And right now, because both photocells are exactly equal to one another, it stays detached and it's right there. So as I increase the brightness to this, it's going to move towards it. Technically, this would keep moving towards it. And then once these things equaled out, then it would stay where it's at. Okay, so like if I'm looking at these values here, right now they're both 115, so that's why it stops. If then it starts getting brighter on this side, it's going to start rotating that way until this one equals the same, okay, which is easier said than done. But basically, we can control, and again, we have to use some sense of imagination here. Attached across this plane is going to be our, let's stop and let's start this thing over again. So attached across this plane is our photocell, or like our solar panel. Then the photocells would be attached one to this side, one to this side. So as the solar panel rotates, the photocells are going to go with it. And like as it points directly at the sun, both of those photocells are going to be getting the same amount of light. They're going to create the same amount of output, and that's going to cause the solar panel to stop moving. But as the day continues on and the sun moves throughout the sky, one of these is going to get more light than the other, and it's going to keep causing the solar panel to move towards it until both of them equal the same. So again, for this week, I should be able to rotate the one on the right, and I should see your servo turn to the right. I should be able to rotate the one, or just the one on the left, and your servo should move to the left. And then if they're both equal to one another at any point, they're both equal to one another, like say, then it should stop moving. Okay. That's it for this week, guys. You can send that in to me. Again, this part down here is critical. Okay, you need to have your pull down resistors, or pull up resistors rather, connecting A1 and A0 back to 5 volts across a 10 kilo ohm resistor. That's the same ports that we're plugging both of these photocells into. All right. Email me with any questions, ladies and gentlemen. Have a great week. Talk to you soon. Adios.